So today is our first day in quadratics, and that's a really important day because quadratics is really what defines algebra. It's what that big topic is. So we're going to take our time as we work through these. There is quite a bit of vocabulary, so we're going to spend a couple days just trying to learn the vocabulary and what it means. So the first thing I want to talk about is how do I know if an equation is quadratic? If you remember back in polynomials, if our x squared, if that 2 is our highest exponent, that tells us it's quadratic. So anything that has a y equals x squared, and there's not an x to the third or x to the fourth, just x squared, you know you're in quadratics. Anytime we graph a quadratic, it's going to look like a perfect U. And that perfect U is known as a parabola. So if you look at a graph and you see this perfect U, now when I say perfect U, it's going to be opening up or down, not side to side. That's something different. So up and down is a perfect parabola, and that would be a quadratic. So let's just look quickly at some of the vocabulary we're going to need to know. And I'm going to start at the bottom. I'm going to start here with the words, with the vertex. So vertex is the top or the bottom of the parabola. It's really your starting point. Where do I go first, and then how do I figure out what to do next? So you want to go to your vertex first. And the vertex is a location. And locations, when we talk about a location on a graph, is always written as an ordered pair. So in this particular graph, our vertex, or the bottom of our parabola, is at -3, -4. Now, from the vertex, we have a maximum or a minimum because it's either the very bottom or the very top. So the very bottom would be a minimum. If you're at the very top, you have a maximum. So at the very bottom, we have a minimum. Here, our minimum is -4. It's important that you notice that it's just a number. It's not an equation. It's not an ordered pair. It's how high or how low will this go? And it will go as low as -4. If it was a maximum, we'd ask, well, how high will it go? So it's about how high or how low your graph is going to be on when you put it on your graph. Now, let's go ahead and switch over to domain and range real quick so that makes a little bit more sense. The range of a parabola starts at its maximum or minimum, and then it goes forever in whichever direction it's opening. So if you think about a parabola, it always is drawn like a line with arrows on the end. And as it's a U, it's going to continue to grow and continue to move in that direction. So it's always going to be moving out, and it's always going to either be moving up or down. So the range is where does it start, and am I moving up or am I moving down? So greater than or less than. It's always equal to whatever the y value is of your vertex. So in this case, the range is y is greater than or equal to -4 because it's going up and it will go up forever. Now, as I said with the domain, as this continues to grow, it's going to grow out. And as it grows out, it will never stop. Therefore, the domain really starts at -infinity and goes all the way to +infinity. And we just call that all real numbers. So we could say -infinity to +infinity, or all real numbers, and all real numbers is just easier to write. So make sure you understand that when we see a parabola, that's going to be our starting point. Now, if these are word problems, there are limitations, because in real life, there are limitations. So it may not go as far, but it's a good idea to know exactly what that parabola is doing. So we talked vertex, maximum, minimum, domain, range, y-intercept. You know what the y-intercept is. It's wherever the parabola is going to cross the y-axis, and it should be written as an ordered pair because it's a place on a graph, and all places are written as an ordered pair. It's a location. So now we're going to talk about the terms that are probably the newest. Axis of symmetry. Axis of symmetry up here at the top, also written as AOS, is the invisible line that makes this U symmetric. So think about a butterfly. You're dividing it in half, so if you fold it in, the wings will fold in and be the same. That's what this is about. We want to be able to fold it in, and it's really going to help us out in our next section when we start graphing. So the axis of symmetry, if you notice, is this dotted line. because it's invisible. It's not really part of our equation or our function. It's just a line that we use as a guide or something to help us. It's written as a line, and an equation for a line, if you remember back, and I'm going to remind you of VUC, so vertical line, right? Undefined slope, and my equation be written as x equals. So here, it's x equals -3. The axis of symmetry is something you are going to need to find multiple times. So make sure you understand that it is that invisible line that we draw like a dashed line right through the middle, and as it's a vertical line, we write it as x equals. So it does need to be written as an equation. And then one more section. This is what we will be building up to, the solutions of a parabola. And solutions can be known as roots, they can be known as zeros, they can be known as the x-intercepts, which I think is probably the easiest way. If they would just always say x-intercepts, you'd know exactly what to do. But they don't. All four of those words can be used interchangeably, and they all mean the exact same thing. When I want to talk about the solutions of a parabola, of a quadratic equation, all I'm looking for, the only thing I'm looking for, is where does my graph cross the x-axis? That's all I want to know. So here this parabola crosses the x-axis at -5 and -1. Those would be known as my solutions. And many times it won't ask you for the actual number. It'll say, well, how many solutions are there? Well, the solutions to this particular parabola, this particular quadratic, is it crosses in 2 places. So that makes it 2 solutions. If my parabola only crosses once, which is what will happen when we don't have a shift up and down, when it stays on the x-axis, there will be 1 solution. And many times it gets shifted up or down beyond the x-axis, and if it does that and your parabola does not cross, then we call that a no solution. So you can have no solution, 1 solution, or 2 solutions, or zeros, x-intercepts, roots. So that is your basic overview of quadratics. The fact that a parabola is the U-shape that is made when you graph a quadratic. Axis of symmetry, your y-intercept, your range, your domain, the maximum, minimum. There's quite a bit of vocabulary here, so we're going to take our time working our way through this.